Good evening, everybody. We are nearly ready to start tonight's Elite Dangerous live stream. We'll be counting down 5 minutes, where I'll be joined by some special guests talking about the sounds of space. Hello everybody and welcome to tonight's Elite Dangerous livestream. I'm very happy to present to you another episode of the Discovery Scanner livestream series, which takes a look behind the curtain at how Elite Dangerous is designed, created, and we've woven into magic and science and all those things. I'm sure it made sense. It did make sense in my head anyway. Welcome. How is everybody doing? Do say hello in the chat. I see all of you out there on YouTube, Twitch and Mixer watching. There you go. Just going to take some water because I've got some guests beside me. So tonight's live stream is titled The Sounds of Space. I don't even know what that means. Well, you will know what that means tonight. So I'm joined by the lovely, and I'm going to look at this right here because I haven't forgotten his title, Space Weather Research Scientist Nigel Meredith. Hello, Nigel. Welcome to the live stream.
Thank you. It's a pleasure to be here.
And next to him is our very own principal audio designer, Joe Hogan.
Hello.
Welcome.
Thanks for having us.
You are, you know, responsible for a lot of the sounds that Elite Dangerous has. People do like to share a lot of the time their love for and appreciation for the sounds. But you, Nigel, you get to listen to real life sounds from space, real sounds. Whereas you kind of
we make it up.
We make it up. Not all of it.
Not all of it. But not of it. Not anymore.
Yeah, no, it's been good. It's been good to be to work with Joe and you guys to kind of incorporate some of the sounds which we'll be talking about tonight into the game.
Yeah. So before we begin, Nigel, could you maybe introduce who you are and who you work for? You work for the British Antarctic Survey.
Yeah, okay, so as you've just introduced me, I'm a space weather research scientist at the British Antarctic Survey, where I develop global models of natural radio waves in near-Earth space, and these are essential for our space weather models and forecasts, which we develop at the British Antarctic Survey. And I'm also interested in extreme space weather, and I've been doing work recently on determining the 1 in 10, 1 in 50, 1 in 100 year space weather events. And I suppose I should introduce BAS, as people may not know what BAS is. Well, we basically, we're based in Cambridge with over 400 staff, and we operate the UK's polar research infrastructure, both for ourselves, our own scientists, and for the UK and international communities. We're part of the Natural Environment Research Council, which is also a part now of UKRI, which is United Kingdom Research and Innovation. And our purpose is to carry out scientific research and surveys in polar regions to better understand the Earth and our impact upon it. And our scientists study all aspects of polar research, from the ocean depths to outer space, including marine ecosystems, ice and ice movement, geosciences, the atmosphere, and of course, space weather.
Awesome, awesome. That sounds like a very meaty topic, and you're no stranger to doing sort of these talks. You've done quite a few talks on the sounds of space.
Yes, we've started off. We've been doing some collaborations with artists and musicians, and also yourselves. Yeah. And so these have actually been coming together in tandem. Yeah. And at the same time, I've been giving talks on the sounds of space as well, which actually developed from a poster that I put together for outreach. And then when I first met Matthew Floriance at a Data as Art event, he said, can I come along? And he expressed an interest in the sounds. And he said he'd be bringing his David Braben with him. And he sent me a link to David Braben on Wikipedia. And I thought, actually, this PowerPoint, is this poster's just not going to cut the mustard, you know? So I actually spent probably the best part of a week converting the poster into a talk, which I then gave to David and Joe and Matthew when they came to visit us.
Yeah, and I think we're going to talk about that, or sort of Joe's going to mention about how that came together. And it's worth mentioning that we're kind of looking at this now because it's been almost or just under a year since we introduced the FSS, which is the full spectrum scanner, which commanders out there in Elite Dangerous can use to tune and find all sorts of different things, different interstellar bodies and signals, and all of this actually comes from that meeting where Bass and the Elite Dangerous team got together and incorporated it. But before we kind of talk about that side of things, because that's super interesting, I know I'm biased, but Joe was talking to me about it earlier, and saying, yeah, we layer these sounds, and I don't want to speak for him because he's going to do it much better than I am. But it's really cool, it's really exciting. But let's dial back because I'm getting ahead of myself. Let's talk about the sounds of space. What does that mean, Nigel? What does it mean?
Okay, well, it turns out that our planet naturally produces a wide variety of radio emissions, and these radio waves are generated by lightning activity and geomagnetic storms driven by the sun. And we'll talk about that a little bit more later. They're basically at the lower end of the radio spectrum, between about 10 hertz and 10 kilohertz, and they're best detected by large antennae, either on the ground or in space. And basically, the radio spectrum covers a wide range of frequencies below 300 gigahertz, and of course, mankind uses it for a variety of applications, from TV through radio, Wi-Fi, GPS, mobile phones, satellite communications, etc.
I think we have a little
Yes, we
image
do.
of that. Am I right? Thinking of the signals. I think we've got something there.
If we've
That's-
got that,
yes,
it might
and
be
it's-
helpful to show it.
There we go. The radio spectrum.
Yeah,
Here
so
we go.
there's the radio spectrum, and it covers orders of magnitude in different frequencies, like I said, from 300 gigahertz downwards. And what we're talking about today is Earth's natural radio, and that occurs at the very lowest end, so that's off to the left on that scale, between 10 hertz and 10 kilohertz. And what's interesting is that this frequency range roughly corresponds to the frequencies which we're sensitive to in the audio range. So,
Right.
so these are the when we're listening to sounds, we're basically sensitive to sounds in the same frequency range. Now, Earth's natural radio is a form of electromagnetic radiation, so we cannot hear these emissions at all. But what we can do is we can convert them into sound, and then play them back so that we can then hear the sounds of space. And that's essentially what we're doing. We're converting the radio waves into sound. And we don't have to do any manipulation with the frequencies because they're in the same frequency range
just
as
capturing
the
it all.
human ear. So we're just converting them directly to sound.
Great. And we're going to hear quite a wide variety of sounds. But before we do that, we've got a nice image here. Can you talk us through this image, Nigel? What are we looking at here?
This is our VLF receiver, which is located at HALLEY Research Station, which is actually a great location to record these sounds, because it's actually magnetically connected to a region of space where some of the waves I'm going to talk about tonight are generated. And it's far from man-made sources of electromagnetic emissions, so it's a very quiet site. And what we're seeing here is the receiver, which is two orthogonal loop antennae. They're 58 meters squared in diameter. I think the height there, I once worked it out, I think it's about the same height as two double-decker buses, one on top of each other. And we can basically think of this as a huge microphone to detect the small magnetic fluctuations that, of the low-frequency waves. And the detector picks these up. We then amplify them, process them electronically, and the signals are subsequently digitized at, I think, 96 kilohertz, they tell me.
Wow, wow. And it's the little rings, am I right?
Yeah, when I first saw that, I thought it was an electric antenna, but it's actually a magnetic antenna, and so it's the the two kind of square shapes that you can see on their sides are actually, and they're kind of orthogonal, so they're getting picking up the signals from different directions.
Great. Okay, so I think we're going to move on actually. So we've got there's lots of different types of sounds.
Yeah.
How do you want to go through this, Nigel? Do you want to we're going to talk over about them all, or we're going to go and dissect each little one? We've got quite a collection.
I think what we'll do is I'll just give a little introduction to each one, I think. And we'll start off with talking about the main signal that our VLF receiver or any ground-based receiver will detect. The signals come from lightning activity. And what happens is each lightning flash emits a short radio pulse, which is known as a spheric. And this covers a wide range of frequencies. And these are heard as short cracks, they sound a bit like static, or maybe hail hitting the pavement. And the interesting thing for us is that the SPHERICS that we detect at HALLEY come from the Amazon and Congo basins, so over 8,000 kilometers away. So, shall we play our first sound?
Yeah, let's hear it. I think it's going to work for us. We've got a, yeah, I think we're going to. So we're back. I think, did everybody hear that? Everyone, you might start to sort of recall what you might start to hear these sounds, because if you've been playing Elite Dangerous, I think there's quite a lot of crossover with some of the bass sounds. We'll talk about it later. I'm going to stop getting ahead of myself. So Nigel, talk us through what that was. I know you just briefly mentioned it, but
so these were, yeah, we heard the SPHERICS from lightning there, or some of us did. We didn't. But hopefully we're going to hear some more as we go through the show. But SPHERICS can travel even further than the 8,000 or 10,000 kilometers or so that we're detecting the ones from in the Antarctic, and they can actually travel up to halfway around the globe. Wow. And when they do this, the signals become slightly dispersed, meaning that some of the frequencies, the higher frequencies, come back slightly faster than the lower frequencies. And what we have now is what we call a tweak, and these have a pronounced kind of ringing nature, and they're the first evidence that some of these sounds may actually have a musical nature. So shall we hear a tweak?
So this is a tweak. This is kind of a musical.
Hopefully.
Hopefully. I feel like it's a little bit like popcorn.
Yeah.
Popping.
Yeah, no, it's great.
It's got a bit of a twang quality.
Yeah,
Isn't
yeah.
it?
Or things popping. So that's a tweak.
Yeah.
Okay. We've got this lovely diagram, Nigel.
Yeah,
I can't pretend to know what this means. But
okay, well
talk us through.
that kind of blue semicircle is the Earth.
Yeah.
And what we see there are the Earth's magnetic field lines. The Earth basically has a magnetic field, just like a magnet does. And the magnetic field lines extend out into near-Earth space, out to about typically 10 Earth radii. But why I'm showing this is because some of the signals from the lightning, some of the radio waves actually leak out into space and then travel along the magnetic field line. They're kind of guided, if you like, by the magnetic field, and then picked up in the opposite hemisphere. And here we really see dispersion in action, because the higher frequencies travel faster than the lower frequencies. So what started out as that spheric actually comes back as a descending tone. And we call this a whistler. So shall we have a listen to a whistler?
A whistler. I think these are my favourite. I like the chorus, but anyway, sorry. Pure note whistler, this one.
So that one's a pure note whistler. That's kind of travelled along field lines that are relatively close together. But most of the whistlers that we detect at HALLEY tend to have travelled upon, to get there, they've actually travelled on multiple field lines, if you like, and so they've travelled slightly different distances. And so what comes back is what we call a diffuse whistler, and I think you'll notice it has a sort of slightly more kind of swooshy tone. So shall we take a listen to that?
Yeah, let's have a listen.
It's got a kind of shh quality,
It's like
hasn't
there's
it?
something in the background kind of whizzing, like, and then there's the crackle.
Yeah, we've still got the SPHERICS in there as well, of course.
Yeah. So, this is not the only type of whistler, though, that we've got the diffuse, we've got the pure note. There's more, I believe.
Well, sometimes the whistlers can bounce back and forwards, so they can not only be received in the opposite hemisphere, but they come back, and sometimes they can hop multiple times.
Okay.
We call this a whistler train, and each successive received whistler becomes more dispersed as the signal obviously is travelling further with each bounce. So shall we take a listen to a Whistler train?
Whistler. There you go. By the way, Nigel, who comes up with these names of all the different sound classifications, like the Whistler train?
I think that's just evolved over the years.
Okay, it's just something that sort of sounds...
Chorus I can explain later.
Yeah, sure. Okay.
Whistle, obviously from whistling, but
Yeah.
the train is quite cool, isn't it? I suppose you're thinking of different carriages
Yeah,
for each one.
and it kind of sounds, it's that back and forth.
Yeah.
Almost sounds like a carriage. Each carriage, I don't know. I'm trying to make sense of it all. So these aren't whistlers, these triggered emissions, Nigel. This is it a whistler? Or?
No, well, actually, sometimes what we find is sometimes the whistlers can excite additional radio waves as they travel along the field line. But when I first heard these, I must admit, I thought, well, there's probably a bug in the system. They didn't sound real. And then I spoke to colleagues and they said, yeah, these are triggered emissions. And actually, they sound rather amazing. So shall we take a listen to some triggered emissions?
Triggered emissions. That was quite a short one. It's just a...
Yeah, I'm not quite sure what happened to that one.
Oh, it might have cut off there. We'll try and listen again. It might have...
The end of it, I think...
Oh. We're good. We're all good. We're all good.
Yeah, I think we heard the end of the triggered emission
Right,
there,
I
because
see.
it kind of started off with that, and then you get the
then
ping,
it's-
ping, ping, ping as other things
It's
happen.
like it's echoing off things, or
Yeah.
a big cluster of them or something. Yeah.
But they're fascinating signals as well.
Okay, and then we have Van Allen whistlers.
Yeah, well, this is, I should say these are whistlers from the recorded now in space. So if you like, everything we've heard so far has been detected by the VLF receiver at HALLEY. But now we're going out into space and we're going to listen to what instruments on board the Van Allen probe satellite actually record in space. So now we're actually, because we're above, if you like, the Earth's atmosphere, we've now removed the spherics and the tweaks. So you get the pure sound of whistlers. And I should say that these now are not bass recordings. These are courtesy of the University of Iowa, and it's a great pleasure to share these with you as well today.
Awesome. let's have a listen. So I like this one because for me, and I mentioned it earlier, but it sounds like a sort of 50s cosmic sci-fi intro with all the zaps and the boo, 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 boo.
Yeah, it
Doctor
is
Who or
quite
Yeah,
amazing.
it's got that kind of cosmic whirl, I call it,
Yeah.
maybe. Okay, so we get to move on to, I mean, if there's anything else you want to say about whistlers, Nigel, or we get to
I
go on
think we
chorus?
can move on to chorus now. Yeah.
Tell us what the chorus. What's a chorus? I mean, it sounds musical in nature.
It does, doesn't it? Keep them guessing. So, another prominent signal type which we observe is, we call it chorus, and it's generated now deep within the Earth's magnetic field itself. And what happens is we have energetic electrons enter the Earth's magnetic field during geomagnetic storms, which are driven by the sun. And these storms cause multiple effects, including the Earth's beautiful aurora, and at the same time, similar processes generate chorus. And the most common form of chorus consists of rising and falling tones in the frequency range between about 1 and 5 kilohertz. The emissions are called chorus because I think you'll find sometimes they resemble the twittering of birds in the dawn chorus. So shall we hear an example of chorus?
Let's hear it. It was like the twittering of birds there, especially at the end, sort of these little chirps here and there.
It's amazing, isn't it? So that's why these emissions are called a chorus.
Nigel, before you continue, we are going to try our best to answer questions sort of after the stream. We do have Paige and the moderators in the chat who will be helping to take down questions, but there was a question from Ben that I believe we can answer right now. It's about the availability of these sounds.
The signals at BAS we're always happy to share with people for people to use in their own projects, for example. And if anyone's interested, then they should contact me, basically.
Contact this guy. I mean, they can go through the website to contact you, or
they can email me.
Yeah.
Maybe we'll leave my email address at the end. And I'd be delighted to get in touch.
Yeah. There you go. So I believe we have quite a few chorus, if I'm not mistaken. Looking at my notes here. Yeah, we've got a few more examples.
Yeah, I thought I'd share the next one with you because when I was looking through the sounds to select them for Joe, I thought, well, let me take a day when nothing should be happening. The sun's quiet, there's no activity. Let's just see what nothing sounds like, just to get an idea of the background. And I chose this day, and then I found some of the most amazing signals ever. And this is an example of one now, and it just shows that sometimes the chorus signals can be more widely spaced, exhibit unusual complexity. And let's take a listen to this one.
It's like kind of stormy almost, though, sort of in a valley, sort of a windy valley with these birds chirping. I mean, I'm still going with the birds chirping. Yeah. It does sound like that.
It's totally different, though, isn't it, from the first example, which just shows the amazing variety of the sound.
It scoops upwards as
it
well.
does, yeah, if you look at the spectrogram. It does, yeah.
Right, and we've got sort of another one.
Yeah, this one I thought I'd share with you because it's an example of chorus detected in space. And again, this is from the emphasis instrument on the Van Allen probe. I think it was the Van Allen probe B that took this one back in 2012 at the start of the mission. And yeah, let's take a listen to chorus in space.
A lot of clarity on that one. So
yeah,
because the SPHERICS weren't there.
That's right.
Very clean.
So it's great to hear these sounds in space because the SPHERICS are no longer present. But of course, Joe with his magic can get rid of the SPHERICS anyway, and he'll talk about that later.
No spoilers on that one. we'll get there. But no, I really like these ones. We've got some other ones that are coming up that are really we start to go into some deeper into space now.
In a minute, I think we've just got some hiss.
Yeah.
Yeah, because plasmaspheric hiss, this is another important emission, and it's so called because it resembles audible hiss. And this is a broadband structureless emission, and it has frequencies typically between 100 hertz and several kilohertz. So shall we take a listen to some hiss?
Zone out the crackle, you can hear it. It seems very sort of
constant tone, isn't it? We said earlier it sounded a bit like the traffic on the A14, and then I remember one of your colleagues telling me it doesn't always sound like that because quite often it's not moving. So that analogy doesn't always work.
I'm really glad you said this one as well because I had trouble earlier pronouncing plasma. Let's see, here you go. Plasma. I can't say it.
Plasmaspheric hiss. Yeah.
Thank you, Nigel. That's good. Okay. That's his. And now, is that separate from a chorus? Is that linked in some way to a chorus?
How did you ask that question? That is an amazing question, because actually there is a link between chorus and hiss, and one of my colleagues that wrote a Nature paper on that back in 2008. You get the chorus kind of be generated a little bit further out, maybe 5 or 6 Earth radii, and then it travels along the field lines and it can bounce back into the plasmasphere and be a source of plasmaspheric hiss. There are many sources, but chorus is one of them.
Well, I don't know. Maybe it's rubbing off on me, and I'm kind of, I get it now. It's clearer. Let's.
It's actually awesome question.
Yeah. Let's move deeper into space. I say now we've got sounds from Jupiter, and that's what it says on that slide.
Yeah, we've got this coming up now because having explored natural radio on Earth, it turns out that natural radio can also be detected on each of the gas giants, and we have recordings of chorus from Jupiter, Saturn, Uranus and Neptune. But for today I thought I'd just share a couple of the sounds that we have from Jupiter. And this audio clip we're going to play you now was recorded by Juno as it approached Jupiter back in 2016. And these emissions were recorded at a distance of about 9 million kilometers from the planet.
Wow.
And this is the Jovian bow shock, where particles streaming from the sun first encounter the planet's massive magnetic field. So let's listen to that. From the spacecraft, a shock. 2 totally different environments.
It sounds like it's crashing. It's just crashing down. That's awesome.
Yeah, it would have spent years on its way there in kind of interplanetary space, and then suddenly, bang! It hits Jupiter's magnetosphere. So
awesome.
I think that's fantastic.
Yeah, it's an awesome sound.
Yeah.
So next up, I think we have a whistler.
Yeah, I mean, this is kind of quite fascinating because it turns out that Jupiter has lightning storms just like we do on Earth. And this audio clip contains a couple of whistlers from Jupiter, which were recorded by Voyager 1 back in 1979.
Oh, wow. And we're going to hear them in just a minute. Are these very different from the ones we played earlier?
These actually sound a little bit different. I mean, it's interesting because the Voyager spacecraft was in a rather special place when it picked these up. And I think normally at Jupiter they're harder to hear, but it was in an environment where it sounded a bit like whistlers at Earth. If anything, the dispersion is a little bit longer. Shall we take a listen to it?
Hear it.
It's clearly different from the Earth one.
That's you kind of really you hear it behind the kind of, but it's like,
Yeah. It's a bit like a lazy Earth whistle. isn't
Yeah.
it? It's like it's not got its act together. Just a different plasma environment.
and then of course bringing it back round from whistlers to chorus, which we
Yeah, I mean, it turns out that the chorus is also generated in Jupiter's radiation belts, and this is a clip of chorus recorded again by Voyager 1 back in 1979, and these are higher frequencies than the chorus at Earth.
It's less sort of a tweety sound. It's quite. I find it quite
it's
harsh.
a bit metallic, isn't it? I think.
So why is it high pitched?
Again, that's just the different processes that are taking place there. Yeah, and that's just, of course, one example. If you imagine if we move around the Earth, we've only played a couple of examples today. There's all kinds of examples are collected, and you know, they're very variable. But certainly, that's a higher frequencies than we tend to see it most of the time on Earth.
So we are moving away now from Jupiter. We're going to Saturn. Saturn
yeah,
radio
I
missions.
thought I'd share this one with you. This is one now they've kind of cheated here a little bit because these are now not generated in the audio frequency range.
Okay.
But what the Cassini scientists did was they converted them they shifted the frequencies, if you like, so that we can hear them. So for the poor people that unfortunately cannot hear their sounds, they can cheat. So it turns out that Saturn is also a source of like really intense radio emissions. And this clip was recorded by Cassini back in 2003. It's also courtesy of the University of Iowa, as most of these space sounds not from Earth are. And it's one of my favorites. It just sounds, well, I'll let you listen to it. It's totally incredible.
Let's go.
Settling, isn't it?
It's quite ghostly.
Yeah.
I know, it is incredible. When I gave my talk a couple of weeks ago, I said that it was like, you know, it'd be really good to sort of open the door on Halloween with that playing in the background. Right. Take that!
Well, yeah, it's quite
trick or treat.
Yeah. It's quite solemn.
Yeah.
I liked it.
It is. I mean, when I first heard that, I kind of imagined myself in some kind of world where I couldn't understand anything, and wherever I looked, there were like just strange things happening. They weren't necessarily evil, but just the wonder of it.
Yeah.
And it was blue. I don't know why.
There you go.
There you go. Blue there.
Yeah, well, it all comes together.
Yeah.
It's worth mentioning, if you are just tuning in now and you're wondering, what are all these weird noises we're listening to? So this is our Discovery Scanner series, where we look at sort of the deeper mechanics and creation of Elite Dangerous. We sort of go behind the scenes and see how the team put together many of the features, designs, 3D designs, art and sound. But Nigel here from the British Antarctic Survey is talking us through sort of the real life sounds, and then what we're going to do is we're going to explore the other side of things, of how they became part of the game in what we released almost a year, or just over a year ago, in Beyond Chapter 4 with the full spectrum scanner. Right, sorry, little segue there, but it's going to move us on to pulsars. What are these?
Yeah, so we're going to move now beyond the solar system and listen to some galactic sounds. So pulsars, they're highly magnetized neutron stars with a mass typically greater than the sun, but a radius of only 10 to 15 kilometers. So I think they say if you put a little bit of neutron star into a teaspoon, it would weigh more than 100 million tons.
Wow.
If you can even understand what 100 million tons is. But what happens is radiation is beamed out along the magnetic poles, and pulses of this radiation can be received if the beam crosses the Earth, a bit like a lighthouse, if you like, if it comes round. And what we have here is, what we're going to play first, is a recording of the brightest pulsar in the northern sky from the Lovell telescope at Jodrell Bank. And this one, it has a rotation period of 0.7 seconds. So let's take a listen to this one.
Almost feels like it's going sort of on a rate, like a circular motion.
Yeah, that's right. It's a little bit like a heartbeat, that one, isn't it? It's just,
And then sort of, you know, as you're on a live stream and nerves kick in, the next one is a little bit.
It turns out that different pulsars spin at different rates. And this next one is a recording of the Vela pulsar. And this is from the Parkes Radio Telescope in Australia. And this one's rotating about 11 times a second.
It's like a helicopter.
It is a bit like a helicopter, isn't it? Yeah.
Tapping, or
it's a good one.
Some annoying person in the office tapping.
It does.
Yeah.
Will Stephenson said the last one sounded a bit like the end of a record. So when the record stops.
Oh yeah.
It
did.
jumps over
That's
the
a
track
good analogy.
each time,
Yeah.
It's quite nice.
Cool.
Awesome on that one.
Yeah. Thanks.
So, yeah, they're quite fascinating sounds. They're They're very different from anything we've heard thus far.
Well, they're more like beats because these are signals that radio telescopes pick up. So we're just playing back what they pick up rather than having the specific frequencies. We've just got they're just playing a sound as the signal kind of kicks in.
Right.
Yeah.
Okay, and then we've got the millisecond pulsars.
Yeah, so we'll just finish off pulsars with this one because some pulsars can spin a lot faster. And this what we're going to hear now is a recording of the brightest millisecond pulsar, also recorded by the Parkes telescope. And this one is rotating at 174 times a second. So
now, before we play this one, I might have got these confused, but is this the one that sounds really, really painful sometimes?
it's the one that sounds like an angry bee. And I think we heard it earlier, and it didn't sound quite as bad as it did when I played it during one of my talks.
Right, okay, let's hear it, because it's quite strange. Hopefully it won't break your ears. It should be fine.
Or destroy your speakers.
Yeah.
Are we...
That one is
Amazing.
it's a bit horrible.
Yeah,
I have to say.
it's a bit like an angry bee, and I guess that's one that won't be included in my game.
Well, it depends how nice the players are being to us at that time,
Yeah.
maybe.
Unless you want to disable your enemy.
Well, there you go. You just play that. It's a
Yeah.
horn for the spaceship.
Yeah.
So moving on now, we're still in the galactic sphere of things, but we've got merging black holes next.
Yeah, we're now going to actually leave our galaxy behind. See what we can pick up elsewhere.
Bye.
Now, gravitational waves that were first predicted by Einstein back in 1916, and they were finally observed nearly 100 years later by the LIGO interferometers in America. And this was the first detection of these waves, which are ripples in space-time produced by violent events like colliding massive compact stars. And what we're going to hear now is a chirp, which comes from the merger of two black holes that took place 1.3 billion years ago.
Wow.
And apparently in the last moments when they were merging, they gave, the energy in the gravitational waves was equivalent to more than 10 times the light power of every star in the known universe. So let's get ready for this amazing sound.
You've really hyped it up, Nigel, so let's hear it.
Money back now.
Yeah, not quite what I was expecting, if I'm honest.
But I think what we have to think about is that this has travelled for 1.3 billion light years.
So we're just hearing
and it's detected by one of the most sensitive instruments ever built.
It's comical, this one.
It is, isn't it?
I think the next one is as well.
Yeah.
Similar one. I believe it's colliding. We've got Zulu Romeo here saying whoop, which is pretty much
Fantastic.
Yeah, makes
Cool.
it right.
Yeah, so 2 years later, the LIGO interferometers made the detection of gravitational waves from two colliding neutron stars. And this took place 130 million years ago. And it was the first ever cosmic event that astronomers managed to observe in both light and gravitational waves. And the light-based observations showed that heavy elements such as platinum and gold were produced by the collision. And this was helped to solve the age-old question of where these elements are actually made. Before this, we didn't know where gold and platinum actually, how could they be created? Mm-hmm. And they actually created in colliding neutron stars. Incredible.
Yeah, and we have the sound to accompany this as well. This awesome age-old. And here we go, let's go.
So you got to love
Why
that one.
Why are these ones the most comical of them?
Well, it's interesting because these are no longer electromagnetic waves, these are gravitational waves, which Einstein understood, I don't. But they've got nice sounds. But they are actually VLF, so they're actually in the audible range.
Oh, wow.
That is their sound, but they've been converted by the LIGO scientists, who we must also credit for these two sounds, and played back as sound.
It's quite funny. Duguk here says anticlimactic. I mean, it is kind of in a way. You build, you build up this.
That's right. They are a little bit. It's quite funny because I've been involved in a number of art science collaborations where we actually use these, And what we have to do is use them more than once and play with them.
Yeah, which is a really nice segue. Nigel, I don't know if you planned that one, but let's talk about collaboration because why we're here today is because we have collaborated to introduce some of these sounds into Elite Dangerous. But before going into that vein of things, you do a lot of sort of musical art pieces as well. Am I right?
Yeah, that's right. We've set up at BAS. We've set up a multidisciplinary art science collaboration to exploit these sounds and make them more accessible. And we like to share them. And so I've been working with Diana Scarborough, who's a local artist engineer based here in Cambridge, and she works with visuals and the audio and makes kind of soundscapes. We've also teamed up with Kim Cuneo, who's a leading Australian composer and also the head of the School of Music at the Australian National University. And he's made some beautiful piano music, which I think we're going to share with you later. And so what Diana did was combined the soundscapes, if you like, the sounds of space, and the visuals with Kim's music. And then for our first show, we weren't quite sure what to do. And she said, well, it's not going to work, just the sounds and the visuals in this hall, which was the Anglia Ruskin University. But it's not going to work. And so she said, let's have some dance. Let's bring a dancer in. And I thought, oh, she's gone mad. this can't work, I thought. And so I went to the rehearsal, and within about 1 second, I thought, this is just going to be amazing. And so, we now combine dance with the music and the sounds of space and the visuals. And it just is sublime.
It just all comes together.
Yeah.
I do see a familiar name in our community here, Tokuso, who makes lots of Elite Dangerous themed music. And maybe perhaps this is an inspiration for him to maybe his next track could feature the sounds of space.
Wow, that would be amazing, because you can't, there's so many applications with music. We're kind of combining it with classical music, if you like, but it could also work really brilliantly with electronic music and all kinds of different moods music has. There's plenty of scope for sharing the sounds and not kind of treading on each other's toes.
Sure.
So I should mention that, yeah, Becky Byers and Felix Denton are the dancers that we have working with us. And we recently did a show for the Cambridge Festival of Ideas, just in Eddington.
It was at the end of October, I think.
Was at the end of October, and that went really well. The dancers did an experimental piece where they actually danced amongst the audience, and this was a case of me thinking, no,
what are you doing?
How could this work? But again, it was amazing. And so hopefully, we can take these shows forward. But as usual, it's all about getting funding, so we may have to apply to see if we can get some funding for the dancers. Yeah.
Sure. Shall we hear some of this? I mean, we've got a track, some of the classical music.
Yeah, I think we're kind of nearly ready for this. I should just say that what we've done with this is we've combined some of Kim's music with basically we have a day's worth of recording from HALLEY that I gave him. And then he composed 13 pieces from different times of the day and gave them names according to the mood and the time of the piece. So there was one piece he called like Late Night Jazz. And you could just sit back and listen to it and imagine yourself in the Antarctic at 2 o'clock in the morning, as you do. And this would be what you would actually hear. So what we're going to share with you today is just one of the first track from this album we're hoping to put together, which will be 90 minutes, I think, in length, and it will contain Kim's music, the sounds from HALLEY, and also some visuals of the Antarctic from the BAS image collection. So I think we have we've got one clip.
Yeah, I think it's coming now. It's very relaxing. It's time
Yeah.
for a little snooze now.
Yeah.
But we've still got, we're just over halfway now. So I do feel like we do have to continue. We can't just stop.
Yeah,
Very
gotta keep
relaxing.
going.
Do people feel relaxed after that? I feel relaxed. I feel like I can chill here now. But we're bringing it back to Elite Dangerous.
Yeah, we've got to
I'm afraid.
wake
We
up
have
now.
to, right.
Thank you,
What
Kim.
were we doing? What
And
were we doing?
Diana.
But they do some awesome stuff. You were sort of telling us while that was playing about
Yeah.
the different kind of genres of music that they are able to do with all these different sounds and
Yeah.
blending those together. It's incredible stuff. So Elite Dangerous, we have got some sounds, some of these sounds in the game, but we've got some HALLEY sounds to play because these you'll, if you've been playing Elite Dangerous recently, you should hear some of these, or at least a deviation of them. Joe's going to sort of educate us all on that in just a moment. But shall we just hear them?
Yeah, I'd just like to remind people that most of those sounds that we heard from the ground earlier, the chorus, the whistlers, they were all from HALLEY. And that in the sounds that we played earlier, they were kind of mostly isolated sounds. So what I thought we would do now is just share a couple of what I've called a medley of sounds, because you can hear many different sounds occurring together. And so what we're going to hear now is an interval that contains some SPHERICS, diffuse whistlers, rising chorus elements, and also some steady plasmaspheric hiss. So you've heard all the sounds now, so hopefully you'll be able to identify them.
We'll test you. There you go.
Yeah, I should say that the recordings that we have from HALLEY, we tend to record them for 1 minute. So we have a 1 minute recording every 15 minutes.
Right, I see.
And that works out to be quite a lot of data. And so the next one I wanted to share with you contains some SPHERICS and diffuse and multiple whistlers, and also some relatively weak hiss in the background.
I feel like I'm up in a lodge in Scotland somewhere, and there's a nice little fire going. It's windy outside.
Yes.
It kind of feels like this little cabin set we're in here.
Yeah.
And then we just need like an animated fire here.
Yeah,
It'd be really
we
cozy.
should have that.
Right, next one though, because
Okay, we'll just
we've got the last one.
finish with the last one here, which this contains some rising tone chorus and some whistlers and SPHERICS. But I wanted to share this one with you because there's some hiss in the background that actually varies a little bit, and it sounds a bit like a kind of monster breathing in the background. So take a listen and see what you think.
This one is- There you go, monster breathing.
It sounds a bit like that, doesn't
Yeah,
it?
yeah. Nigel, we are now moving on to the second half of the stream, but can I just say a big thank you for coming onto the live stream. I mean, you're still going to be here, but I just wanted to take this opportunity to thank you for coming, talking to us about those sounds, showing us those, and yeah, it's awesome. It's a real nice, different, varied thing I've never really heard before till this feature came about actually in Elite Dangerous.
Well, thanks very much.
Yeah.
It's a
Thank
pleasure
you.
to be here, and it's going to be interesting now to hear the process that Joe's been going through and actually putting them into the game.
Yeah.
So yeah, I'm looking forward to it.
Awesome. Yeah, guys, share your comments right now. We are still sticking around. We've got the next half, which is how these sounds end up in Elite Dangerous. But yes, so I know you kind of touched upon it briefly earlier, but how did this come about, Joe? How did we get to this point where these sounds are now in Elite Dangerous?
Yeah, so as Nigel said, my colleague Matthew Florians, who's principal sound designer here, by complete chance bumped into Nigel at the Cambridge Science Festival, and then he came into work the next day and he was just infusing about all these crazy sounds he had heard, and was just like, yeah, you've got to hear this. And I was like, yeah, okay, all right. And then so we organised a little trip where Matt, David and myself, we zoomed over to Bath and met Nigel, and he gave us a presentation very similar to what we've just had. As like the predecessor of that.
Nice.
And I remember coming out of that just with my mind slightly blown that, that you get a giant magnetic ball, the Earth, and just chuck a load of like solar particles at it, and you get crazy noises out of it. It's like the Earth is a synthesizer, and it's like, how unbelievably cool is that?
Yeah, it's really cool. It's really cool.
So then I was just thinking, yeah, we have to collaborate. We have to find a way of getting these sounds in the game, but I just couldn't, especially considering the features we were working on at that point, because we work quite a way ahead of what's out there.
Yeah.
So there wasn't immediately obvious how we can do that in a way that actually makes sense and does the game justice and does the sound justice, you know.
Yeah.
So it was just one of those things just annoying me in the back of my mind, just trying to figure this out.
Yeah.
And then about a year later, everyone started talking about the exploration gameplay and how we were going to overhaul it and just improve it generally, and people were talking about how they want the players to feel like when they arrive at a star system and they scan it, they want more to that. They want the player to feel like a detective, like they're solving a puzzle, and they want the player to feel clever. But the thing that just kept jogging me was they wanted to feel like they're tuning a radio, and I just thought, well, that's perfect for this, because these are these are radio.
Signals.
Obviously, they're amplified so we can hear them, but they are radio. So then I was like, right, this is it, right? So then I started infusing it at game designers and other people, and everyone got really into it. And then, so the FSS scanner, as we know, as that evolved, it was from the ground up. The gameplay evolved with the audio in mind, and that's how we came to be. And that's why it does feel like you're tuning a radio and you're tuning into these signals, because that's the design of it.
Yeah, part of the design.
That was the intent.
Before this live stream, Joe, I came to your office and I said, right, Joe, I've got a big challenge for you. I need you to go back into your memories and remember everything you did for this feature that was a year ago now. So could you maybe remind us?
It's more than a year ago that we're working on it.
Well, there you go, So could you remind us, or at least for those who may not know, because we have some Elite Dangerous players here, obviously, who know all about this feature, but for those who don't know, could you just maybe talk us through the feature? I think we can show some stuff as well.
The idea is, originally you'd arrive at a star system and you'd do the Discovery Scanner honk thing, and you get loads of information about the star system, and you can get more data, but that's kind of the core experience. So yeah, we wanted that to be more involved. So the fiction is that when you arrive at the star system, your sensors are overwhelmed by the radiation coming off the star and stuff, so you need to like calibrate your sensors, which is what the Discovery Scanner honk is.
Yeah,
it's
or the official term is the full system scanner, I think. Because I remember we were presenting the feature and Adam Woods kept saying on the live stream, that's the honk. It's like, yeah, but what's the actual
apologies.
No, it's okay, you can still say honk. People know what honk is, so it's fine.
Yeah, the idea is it's just setting out a huge blast of energy, and the idea is that it's like reflecting off all the planets and whatnot in the system, but it's also kind of giving you an idea where the gravity sources are. Yeah. And it's kind of calibrating your sensor so it can filter out the radiation coming from the sun, which is why before you do that, if you just scan the camera around, if you go over the sun, you just get a load of noise, and then you go out, point into empty space, and you just get like a bit of a radio crackle kind of thing. And also, so after you've done the honk, as you move around, there are these like slightly glowy patches. Yeah. The idea is that they're like kind of gravity sources or signal sources. There's something going on there, so you have to kind of point your sensor at it and kind of tune it in and find out what is going on there. And then around the kind of reticule in the middle, there are these kind of white arrows that kind of give you a hint of what kind of signal is going on there. And then you can tune it in with the slider across the bottom. And you can see like kind of clusters of...
and it's like sort of zooming deeper and deeper if they're further away. And
yeah, that's right. So for example, if you, like there it's zoomed in on a gas giant, what you probably find is that actually there's a load of signals where the gas giant is, because the gas giant's got moons, and each of the moons has probably got multiple signals on it. And the gas giant itself has multiple signals. So if there's too many signals there, the sensor can't make sense of it. So you have to zoom in on it, and then you have to kind of tune in a bit more, and then eventually you can zoom in and see the actual planet. That's why there's multiple layers, because there's just clusters of signals so close.
That's a nice summary of that feature.
Okay.
But how do you make that, Joe? How does that become a thing? I'm trying to look for my notes here.
Okay, well, I was going to just focus on gas giants to start with.
Okay.
So there's a video about to show you which is tuning into a gas giant. In this case, it's Jupiter. So you can hear the kind of tuning of it, and you can hear like the signals from Jupiter, and they're kind of quite crackly and full of interference. And then you tune in, and it becomes nice and clear. And the signal is all the signals we've got. They're initially perceived to be mono, but they're panned around, which gives you a hint of if you have to kind of pan to the left or right to find it.
So you can ascertain that.
You should be able to, yeah. And then when you actually zoom in on the thing, it surrounds you. It becomes stereo and fully surrounds you. So that's what you see in the video. So you can hear all the signals of the planet all piled on top of each other. But then I've also just soloed them one at a time, so you can hear the individual layers. And then at the end of the video, you can just hear it all again, just to remind yourself.
Okay, let's hear it. Let's hear it, because I think you'll.
Okay.
Well, so, Joe, that was a nice little show because that's very clear. There were lots of different individual sounds. I'm not sure that's always how it comes across. You mentioned layers just a minute ago. What does it mean?
It means multiple sounds playing at once, just layered on top of each other. And there's various reasons why we do that. The main one is so that we can parameterize them and manipulate the layers individually. Also, you can have all sorts of combinations, like you might have, for example, an Earth-like world that's inhabited, and therefore you want the sound of human radio comms on it, but you might have an Earth-like world that is not inhabited.
Right.
You might have a rocky world that's got an atmosphere and another rocky world that doesn't have an atmosphere, so you've got like different... The idea is there's like a core sound that's the planet class, and then there's sweeteners that are added on top according to additional properties of that world.
So,
if that makes sense.
Yeah, I'm going to horribly, ignorantly kind of butcher what you're maybe going to say in just a moment, but essentially you're building a category for each sort of stellar body, which you can then tweak and customize based on, temperature and other things as well.
Exactly.
Which we're going to...
Good segue.
Nice segue, yeah.
Actually,
can we come back
to that?
We can come back to that because I'm jumping ahead, I realise. But maybe before we get to that point, how do you go about starting this process? Because
well, Nigel has thousands and thousands of sound files. There's no way that we could absorb this. So thankfully, he went through and made us like a kind of short list, which was in the hundreds of sound files.
So we can't show all of them tonight,
all the best bits.
Course, yeah.
And then he sent them over to me, and it was going through all these and just trying to make sense of it and trying to think about. I had a rudimentary understanding of what these are, having chatted with Nigel about it, but then trying to connect them to how the game works and properties of planets and how we want it to behave. So there was a lot of kind of toing and froing with people in-house, with designers, with Kay, who's one of the people here who's like an expert on astrophysics and stuff, and also with audio programmers. So particularly with Carl, audio programmers, a lot of toing and froing with him, collaborating with him on this, and trying to figure out how we wanted this to behave and how we wanted all the different elements to sound as well.
It's a very collaborative process. I mean, not just with BAS, but then when it comes internally to work with all those different people and levers. And then finally get to... So you've gone through that process, you've got to a point where you've discussed it, you have a strong understanding of how it's going to work. What's the technical, bringing it about?
Should we have a look at this image? So what you're seeing there is an audio wave editor. So you can see two waveforms on the screen. They are actually the same sound, it's just left and right because it's a stereo sound. That's the way you'd normally look at a waveform in a piece of software, a sound wave. And then the idea is that time goes from left to right. So if you hit play, you can see a cursor move across. And then it's a waveform, so it's basically describing the volume of the sound as it goes across. So you can see loads of kind of vertical lines in it. That's interesting to me because they are the SPHERICS, the loud clicks and pops and stuff. So you can visibly see them there, and you can visibly see that they fulfill the whole amplitude that the sound is capable of reproducing. So now we'll switch to the frequency view. So this is exactly the same sound, but viewing in the frequency domain, which basically means, so it's still left to right, exactly this is the time as before, but going top to bottom to top, is low frequency to high frequency. And then the brighter the color is, the louder the sound at that frequency at that particular moment in time. So again, you can see vertical lines all the way through, which are the clicks and pops. And this is really interesting to me as a sound designer, perhaps less so for other people, but you can see because the clicks and pops are a coloured vertical line that cover the whole height, you can tell that those clicks contain all the frequencies basically. Just every single frequency that's possible is there in that click. And that is the nature of clicks, I guess. So that's quite interesting. And then also you can see that the kind of squiggly lines all the way through the middle, that's actually a chorus sound. So the next clip I want to show you is how we went through the process of trying to extract a clean chorus out of this. So the first stage is to do a declicker. So the software, this is Isotope RX, which we use is just a really cool wave editor. but it's got some cool like audio restoration features. So one of them is a declicker.
And that's kind of how you clean up the sound, I think.
Yeah.
And it's quite interesting because Robert Maynard's just asked, I think you're asking this, but what do you use for clipping detection that doesn't remove the desired pops? I think we're going to go into that.
That's exactly what I'm going to explain. Yeah. So you do the declicker on it, and then that removes the clicks, but you've still got loads of high frequency noise and low frequency noise that are not the sound that you want. So then we strip those away too, and then we end up with a relatively clean chorus. Let's have a look at that.
Let's see. This is.
That moving as well.
There you go. So
yeah,
that's sort of a step-by-step process. I mean,
yeah.
You kind of briefly explained how it works, but you're just.
It's one example of many, but yeah.
Well, yeah, I'm sure.
So then the other thing you can do with this is actually we want the sound of the clicks. We want the spherics separately. So pretty much all the processes that we can do the reverse. So where you're like doing the declick effects, you can invert it. So actually you're moving everything but the clicks. And that's what we end up with on the next clip.
There you go.
Okay.
It looks very simple, like easy to do. I mean,
yeah,
but it's obviously not.
It's really hard, honestly. No, it's good fun. It's good fun.
Okay, so
shall I continue talking about gas giants?
let's keep talking about gas giants. We've got all night, Joe.
Yeah. Okay. Cool. So, so as I was saying before about having the base sound for the planet class, and then we pile loads of sweeteners on top of it. For gas giants, we've actually got 3 kind of core base sounds, and the reason for that is that we wanted. There's so much material that we had, and we wanted to use it in different ways, but also gas giants vary wildly.
Okay.
So you have like basically ice giants, which is like Neptune, for example, and then kind of the classic class 1 gas giants like Jupiter and Saturn. Got to be honest, I'm not an expert on this, but this is what I managed to glean. And then, but you can also get super hot ones, which are class 2, 3, 4, and 5, which can be insanely warm, and their whole composition is different too. So we wanted to at least have the core sound different. So again, the next clip will show you just 3 examples of it getting cooler to hotter.
There you go. I was almost not going to say anything because I might get cut off. But let's have a look at this. I mean, Joe's just introduced it, but I just wanted to take a moment to say, awesome.
There you go. So, lightning.
Lightning.
Yeah.
I just didn't want to interrupt you, Joe. I'm really hesitant because you've got a wealth of knowledge on this topic. And I'm trying to interject.
All my knowledge is second-hand on astrophysics.
Hope for the best and see.
Yeah.
Sorry, lightning
yeah.
stuff. I'll not.
So, as Nigel's explained, the lightning manifests itself in terms of the space sounds in various different ways with the SPHERICS, whistlers, etc. But from a game perspective, we've got all the different classes of planets in the game. We can make some guesses about the nature of the storms on those planets from the type of planet. So we can kind of guess whether the storms are more clustered around the equator or more near the poles, for example, according to the type of planet. And we can also have a vague guess about how strong the lightning storms are as well. So, so we use the kind of latitude to adjust the mix of spherics versus whistlers. And we also kind of, from what we can guess about how strong the storms are going to be, we can increase the intensity of both of those two layers. So yeah, the next video is showing those two different classes of sound and three different layers of intensity for each.
So So layers upon layers there. I don't know if you could answer this, and we haven't sort of covered this before, Joe. So I'm sorry if I put you on the spot. How many layers typically would a stellar body have in Elite Dangerous? Could you answer that?
In the FSS,
Yeah.
usually like 6 or 7.
6 or 7 different sounds laid upon.
It depends on the features of the planet. So if you've got a planet that's like, for example, a gas giant that's got rings, so the rings would be an extra layer. It's got auroras, so that's another layer. It's got lightning storms, which is another 2 layers. So yeah, it's quite a few already.
To pile up there, yeah.
Or you could have like an inhabited world, so it's got like a human inhabited sound, plus you've got the core sound. So maybe it's a rocky world with some icy elements, so that's 2, plus it's inhabited. You could perhaps have an atmosphere on it too. So there's quite a lot of combinations.
That's quite nice actually.
Or we could have rings as well. You can have a rocky world with rings, so you know.
So even more unique sounds all kind of colliding together to make this thing sound as it should. We've got some examples as well, I think.
Yeah, so the next clip is examples of specifically the lightning and how it can combine in a couple of different ways. So there's 2 very different planets that it will show you, and you can hear that in the second one you hear a lot more spherics than whistlers, and yeah, it's kind of a mix change, and
reverse. Cool, let's hear it. Nigel, I'm going to actually ask you to repeat that because it was quite a nice comment on it.
Yeah, no, I'm saying that your players will have not had Joe take them through how he's put these sounds together before, so it must be quite incredible to be learning where all these sounds are coming from and how they've been layered, and to hear the individual sounds and the process that
it's
you know, you guys as audio engineers have gone through in actually putting it together.
Yeah, it's cool.
It's cool.
Yeah, I just thought it was worth mentioning that because it's on my mind as well.
Yeah.
It's just, there's a lot of complexity to it, and there's a lot of detail there that, you know, sometimes you may not capture if you're not really, if you know, you're blitzing through scanning stuff, you might not really listen for it, but there are telltale signs of different characteristics of a stellar body. Anyway.
So back to the base sounds. We're drifting away from gas giants now. So back to the core planetary sounds. So obviously we've got the gas giant core sounds, which we've already looked at, but there's other planet types as well. So Earth-like worlds, rocky worlds, icy worlds, etc. So they all have their own kind of core base sound, which we're going to hear in a moment. So most of the sounds that we've discussed so far have originated from BAST recordings. So now we're kind of, although the Earth-like world sound one does too, although it's got a little bit of rainforest added to it, we're now drifting into sounds that we've just sound designed in using more traditional sound design techniques. So like the rocky world is kind of clunky, rocky earthquake style noise, and then the icy world is like a kind of glacier cracking kind of quality. So these are the base sounds that those classes of planets are based on.
Shall we hear a few? I think we've got a
Yeah.
few examples. There you go. So it's
Cool.
sort of some of the classifications there. But there are additional layers,
Yeah.
layers upon layers upon
Yeah.
layers here to make things sound even more.
So there's a few more sweeteners we haven't talked about already. If you've got a rocky planet that's atmospheric, we just want to describe an atmosphere. So there's a sweetener for that. And also, as discussed before, if the planet is inhabited, as you're tuning into it, you get kind of garbled, kind of human radio.
Yeah,
comms.
as you would expect,
Yeah.
from it.
So that's what this example is.
Let's see.
Okay.
So two little
Okay.
sweeteners there.
Yeah. So now, just a load of examples of all the signals together, just what the planets sound like, and the tuning into them as well. Just some random examples of
To
that.
bring it back round to sort of this is what you'll hear.
Yeah.
This is all of those different steps that are taken, those layered sounds all coming together now to form what you should hear in Elite
Yeah.
Dangerous. Yeah. So Nigel just noticed a comment. I don't know if I can't remember who asked it, so
Scrolled off the
apologies.
screen now.
It's gone off the screen, but
Yeah, it said surely bass can help with the icy sounds, and I was going to say that because actually when we do our performance, we actually start off in Antarctic and we do listen to the sounds of the atmosphere of the past actually popping out from an ice core that's 200,000 years old, and we do that because it has an amazing space-like quality. So if Joe wants that sound,
there you go.
Yeah,
I
send
can
it
do it
over.
there.
There you go.
and you can have some sounds of ice in
Okay.
your icy world.
If we could somehow also weave the sort of merging black hole one in somewhere, Just a personal request, that one. From me. Anyway, we do have some other signals as well. There's even more.
Yeah, so everything we've heard so far is planets.
Mhm.
And a lot of the FSS scanner is scanning for stuff that is not planets. For example, you might find a satellite or a nav beacon or something, some bit of human technology that's just floating around. There's loads of other stuff, because you might find like an asteroid or just like abandoned cargo canisters, or a bunch of ships in combat or something. There's a whole variety of things. So the next one is just an example of what human technology sounds like when you scan for that, and it's kind of like digital radio transmission. It's like some kind of computer system communicating with another computer system or something.
All right, let's hear it. I like those. It's almost like a little robot.
It's cute.
Yeah, it's a cute little robot. We are, Joe, thank you. We are drawing toward the end of the live stream, but thank you for talking us through that process. There is one more, my favourite one. It's a spooky one for me. Do you want to introduce this one, the final sound that we have tonight?
Maybe people can guess what it is.
Yeah, if you guess, you win nothing, but you win praise from all of us. So we've got one more sound. Let's hear it. I mean, if you couldn't guess it, it was on the screen. But if you were just listening, you can still guess. I love that sound. It's just spooky.
Yeah, so the idea behind that is that there's loads of Thargoid stuff that you can find in certain places, like scenarios where you can fight Thargoids, etc., or the things you find on planet's surface, or unknown artifacts or whatever in space. So yeah, that's like a garbled kind of unknown artifact kind of comm signal. And the idea is that that's like their systems communicating with each other kind of thing.
Yeah, well, it does draw us to the end of our Sounds of Space Elite Dangerous live stream. Joe, thank you for talking us through that. It's quite nice, and we spoke about it briefly earlier, but I like the idea of just listening to those individual sounds, and actually they are compiled and put together based on the classifications of a stellar body or whatever it is you're scanning. I think that's just really cool, that you can then tweak those and customize those and change it out. Yeah. It's awesome. Joe, Nigel, thank you so much for joining me on tonight's live stream. I would like to say a big thank you to everybody who's tuned in and dropped by, the mods, of course, for their efforts tonight. Are there any kind of thank yous, credits that you want to, any shout outs, Nigel?
Well, I just wanted to say that most of the sounds we played, just reiterate, were from BAS, but the sounds from Jupiter and Saturn and the sounds from near-Earth space, they're all courtesy of University of Iowa. Mm-hmm. The pulsars, I got those signals from Jodrell Bank. And the gravitational waves, they're courtesy of the LIGO team. And these are all freely available on the web, and people can use them as long as they credit the sources. So yeah, thanks, guys.
Yeah, thank you. Thank you, Nigel. Thanks for coming along and
you're welcome.
Treating us to some sounds of space. Any words from you, Joe? Anything you'd like to say?
Yeah, just thanks for having us. But also just credit to the rest of the audio team as well, because quite a few people helped on this, particularly Carl doing the audio coding, and Jordan, who made the sound design for all the, when you're just tuning in and there's loads of like little bits of radio interference that come in that aren't the signal, they kind of layer over the signal, and he made all of that.
Weaving it all together.
Yeah.
Awesome. Well, that does tie us up for the live stream. Thank you, gentlemen. Right, moving on towards concluding the stream. We will be back next week with another live stream. Details will be posted to the forums. Thank you for sharing your comments with us. We did read them. If you had questions, Paige did write them down. We're going to go and look at those, make sure we get the right answers to them, and we'll also post about this on the forums and on the YouTube channel. So thank you for joining us, and we'll see you next time for a future Elite Dangerous live stream. Bye!